guess this has been a very. I'm gonna put the post in here so that we can follow up. There we go. Yeah. This looks much better now. Much better. Much better. It's always an interesting path, the positioning in here on LinkedIn. Let me go to our chat. I think I finally got the hand in here. We'll go to the networking side, and wow, get quite a lot of people that join here. Here we go. Okay, so let's go ahead with this. I have I think a ton of interesting material for us to go through. I'm gonna at the same time monitor what's happening on LinkedIn because it's something that will help us as we move to the Q&A, and then we see what's coming up next. Let's pick up the latest in the thread. See that Jonathan is here. Cool. Okay. Well, welcome. Venkat. Yeah. Venkat is decided to come in once again. So that's pretty cool. That's pretty cool where we are. Okay. So let's get started with this incursion into the human space flight, arena. I would say a revision on what we've been working on in the last session. Let me start bringing that up so that we know how does the standard work and how can it help as you progress in your in your company and in your line of work. Okay. Okay. So in particular, we'll move us to our presentation deck. And I think what's important in here is as much as we look into the NASA standard STs, STD 3001, kind of know why do we need this and what's kind of the benefit for any company to implement the standard. And the first benefits, just think about how SpaceX has made such a big change, because it's in fact the only company in the US that is able to fly to the moon. I'm going to say to fly to the moon, but it's way more than that. Is the only company that is currently flying astronauts and placing them in the International Space Station. And besides that, and that's what we'll see on screen, the fact is that this standard most likely benefits, I'm going to say us all, but besides us all, it also benefits the companies that are able to launch and retrieve humans. So let's get started with that. The standard itself, as picking up our mirror board, the standard itself, if we if we trust ChatGPT, okay, this was the NASA's spaceflight standard human system standard volume. This is regarding to crew health, okay, and I do think that we do need to start in this one because it takes care of the people, okay. It takes care of how people engage into this. And just confirming, I'm gonna start sharing this on stream, okay. Should be able to see myself, okay. So that's what the standard provides us, okay. Let's go back to our Miro tab. Again, it was approved. The standard is in its revision C, and I've got a ton of links that you guys can later use. What's important in here when we look at the NASA technical standard is to understand why is it needed. So I'll go back to what I asked ChatGPT this week, okay? And it says the NASA standard, also known as the NASA Technical Standard Human, it's a technical standard created by NASA to guide development and design of human systems in space missions. Now, it does the work on, and I'll reference this over here. The standards specify the requirements for design, testing, and evaluation of human system interfaces, includes hardware, software, and operational procedures. It addresses a broad range of mechanics. Okay. Now, one thing that ChatGPT does not tell you, I'm going to be very clear on this. It does not tell you, it doesn't not tell that is applicable to not only the spacecraft, but also for everything. And that's for everything, meaning the spacecraft, the transition elements, and that's clear when you start reading this standard. So that's why it's important not only to trust ChatGPT, okay, but also when you I would say when you later on apply the standard, that it's important for us to understand that the ChatGPT doesn't read yet standards as we know it. Okay, so that's something that I would definitely reference to you guys as you move along in your path of applying the standard. So let's get back to this. I'll frame in, okay. I'll frame in here in our NASA standard. There is a very, very interesting document that tells you what are all the changes, okay, and that's I'll go there to show you right that newsletter, okay. It's the Office of the Chief Medical Officer, okay, for Human Spaceflight Standards, and it's pretty comprehensive, okay. It provides you the overall view, and I like the maintainability requirements. So that's something that if you decide later to check on, I think it's really helpful, okay, really helpful. So let's get back to the Miro board, okay. Again, this gives you all the changes that are needed. Now let's pick it up, okay. Volume 1 over here, technical requirements to support astronaut crew health. I made a couple of branches that can help you on your implementation. Okay, now I think that this is crucial, okay. It considers the human physiological parameters as a system, much as one views of the engineering and design of a mechanical device. Doing so allows this human system to be viewed as an integral part of the overall vehicle design process. I think this is more like we should also think about the comparison to a software system. The idea that we are only mechanical devices, I was thinking more about everything that has to do with, in a software system, the routines usually go faster. So that's something to think about, okay? But for some reason, whoever wrote this agreed that this should be more like a mechanical system, something to think about, okay? Another branch in here is that to understand that volume 2, the focus turns the human systems integration, where the context is about how human crews interacts with the other system. So while one takes care of the person, this one takes care of how the person interacts with the environment. And I would say that this is one of those things where we definitely can and should have the looking into other reference, like the human integration design handbook or the human integration design processes and the human systems integration handbook. That, curiously enough, it's the only place where you see humans in the loop. Okay, humans in the loop are a design feature, are a way to conduct work that is really important as you plan out the way that you build your system. And you see that I've got a couple of comments for NASA that why haven't we considered humans in the loop in both standards? And NASA doesn't. That's really not that interesting. Okay, so that's kind of the overview in here. Okay, this part of the deck provides you the overview. I have not touched yet volume 2. Okay, it's something that I'll do in next sessions, but it's something very, very, very demanding in terms of what will be the requirements that you need. Now, let's pick up from the NASA standard. I want to start diving, because today this is a deep dive into how to apply the standard. Again, being very clear, it's this establishes all the requirements, technical requirements. And in here is where you can see a bit of contradiction, okay? Because the scope of the standard focuses really and a lot. Really important to think about this. The focus of the standard is this NASA's technical standard applies to space vehicles, habitats, facilities, payloads, and related equipment in which the crew interfaces during spaceflight and lunar and planetary, example, Mars habitation. Come on. The way that this is written, of course, if you compare to ChatGPT, is like, I'm going to say, big difference. So trust ChatGPT sometimes, not always, but more important. The way that you'll see the standard moving ahead, and when you plan for this, the standard is heavily focused on the space, on the vehicle, on the space vehicle, okay? It's kind of weird, and you'll see an example from SpaceX very soon, that it's missing the whole part. Okay, so I'm going to travel from here to here. That's the vehicle, correct? And so what happens next? How much time do I stay there? What do I do? All of those things, I truly believe are missing. I really do. A combination of things. Okay, so this is why everyone wants this. This is what brought, I don't know how many X million of dollars to SpaceX. This one in here, human rating requirements for space systems. Okay, so if we follow the link in here, that's it. That's it. This is why people do it. It's the human rating certification process. Okay. And it has a whole definition in here with all the requirements, processes, and standards. That's the next step after you apply this standard. That's how, that's how SpaceX is able to fly people. That's how, we Soyuz in a different, of course, using a different, but is also able to put people up there. And there is a whole human rating certification package and endorsements and how to do the certification. But that's the way, that's why. Okay, so that's why we are doing this. So getting back. So we've got the human rating requirements for space systems. That's the big why. That's the question on now the next mission is going out. The next mission is going out, and we know that Axiom has already selected the astronauts. Each of them will definitely have to pay $50 million. So that's a lot of money to go to space for a week, but that's possible, okay? That's possible. The next one, Crew Deep Space Systems Human Rating Requirements and Standards. It's also good to know, and I'll follow the link to give you an overview of what it is. And this is more tailored, okay? It's tailored in order to meet the criteria. I would say if you want to deep dive, there are, I would say, very, very interesting things on the international system of interoperability standards. A lot of words in here, guys. This is one of them. I'm going to say another key need for human space flight. It's if we are up there, how are we going to relate back and work with people that will need or provide help? So that's another rabbit hole not to do today, okay? But there is enough in here to start building up your, okay, I need to go to the human rating space systems. I need to look at the crude, okay? And then the tailoring is, okay, the tailoring is one of the most important parts over here. Do I mean the tailoring is you pick up NPR 8705 and the tailoring gives you the next one, okay? The NPR 7125. And why did I place in here? Good to know. Let's see what. Oh yes, yeah, I know why. I know now I know why. Okay, the reason it's this. It's because it gives you the effective date and the changes in all NASA from the office of the chief engineer, the standards and assessments and guides. So it's really a good, I'm going to say a good overview when you are dealing with NASA programs to have this link in mind, okay? And of course, hundreds of requirements in there. So be aware of that. Okay, the intent of this NASA technical standard is to be the foundation for the program, project management requirements, and verification documentation. So you start with this. If you want to put someone on the moon, okay, you start with this technical standard because it will provide the requirements that later need to be verified, and also they are the basis of your documentation. And again, NASA is a beast in terms of providing you all the needs and all the requirements for that. But I made your life easy, okay? Because I've moved all of these things into an Excel table that can later help you. And if you have an ingestion in your requirements model, something like those, I can help on that. Okay. Now we know what this is for, of course. Okay. What more? I like the fact that NASA also picked up the life cycle. Okay. So what do you mean by life cycle? So we know the scope from here, correct? We know that the scope is everything. And then they say, okay, what is the life cycle of a part of everything? That's something, okay. It explains, correct? We pick up flight crew, health and technical requirements for the pre-mission, in-mission, and post-mission phases of human space flight. So when you see astronauts training, I think you've seen Jared started to train, and you've seen the new Artemis astronauts, they are in pre-mission. There are all the health technical requirements, and I'll give you a couple of examples of that just and right away. I think they are just fabulous in terms of the way the things that they are needed. Okay, so this is more about why and the scope, okay, and I've mentioned in here what the SpaceX does at that. Now I want to show an example because examples beat everything, correct? So here we go. Let's go to an example of the application of the standard. So if you would be looking into I'm going to say a spacecraft, just a spacecraft. No, well, it could have humans in the loop, but this is mostly the launch vehicle, okay? Launch vehicle system, propulsion, structures, thermal, avionics, and other systems. So think about that as just a part of the launch. The bottom part, okay, if you want to think about that. That's the best way to think about the best and probably the only way. This is roughly a description of all the subsystems. That you could have more definitions like the diagram indicates. And there is a diagram with all, in this case, is the relationships and the interfaces between each one of them. And then in specifically part in here, all of the functional diagrams that specify how the design functions work. Kind of, it tells you what are the parts and how do the parts work. It actually has these two it just has these two things. Okay, that's how things roughly work. And the source is this. It's a straightforward source. But I want to move ahead because I think the other examples are more fun. Okay, and here, okay, it's the Crew Dragon. Okay, and like I was very lucky when doing research for this, because why do I say I'm lucky? Because I found a combination of a technical paper and let me go here. I found a combination of a technical paper and also the NASA's the SpaceX the SpaceX Crew Dragon spacecraft, and in particular they were looking and focusing on the ECLS, Environmental Control for Life Support System. It's a big word, ECLS. There are quite a lot of jobs open for this type of thing, but you need really to be good in fluids and I would say a good understanding of human physiology. Okay, well, biology as well, but physiology. Okay, now the fun part is that SpaceX, and this is like, why did SpaceX put so much data outside? I don't know. I don't know, but the sources are good. Okay, the sources are really good. I like the fact that they've highlighted clearly. Okay, you see structure, nose cone, pressure section, service section, pressure launch, and escape fins. Okay, trunk and capsule. That's obvious. So the part where the astronauts go is right over here. Then in here, some of the particular, well, you need to have a toilet, emergency ventilation fan, all fire extinguisher. Yes, fire in space is not good, but it's possible. But it gives you already an idea of what, how do things exist. Now, the cool part in here, as you drive, so I'm telling you what are the parts, okay? Like it's that we have an excellent, well, I'm going to say excellent because it's the only one that I've seen, but it's really good. It's how was the development of the Crew Dragon ECLS, Environmental Control Life Support System. Just pick up these, okay? SpaceX designed the Crew Dragon spacecraft to be the safest ever flown and to restore the ability of the United States to launch astronauts. I'm going to put these out there, okay? And the next one. One of the key systems. Now, and I'll add this because it provides you an idea of the intent, okay? I'm going to put this as well on LinkedIn because I'm positive we've got more folks looking at this. So it provides a combination of things. One, the intent, okay? And also the execution. And that's like, what I mean by the execution, it means that we know what's happening, okay? It's really, really fantastic. Okay, really, really, really fantastic. Oh, I see. If anyone wants to see a couple of policies, yeah, we'll go there. We'll go that far. Yeah, we'll go. Happy to share more. Jennifer GM. Okay. I see that there is some comments flying around here, and later on, I will pick this more up, Jennifer. Okay, thanks for that. But what I feel it's like really powerful is saying SpaceX designed the Crew Dragon spacecraft to be the safest ever. One of the key systems required, of course, is the environmental control of support systems, which was designed to work in concert with the spacesuit and spacecraft. Well, it's obvious, correct? But sometimes you need people that tell you the obvious. Yep, it's how things work. Really, really fun to have and to see that keeps happening. Okay. Now I want to move you to the next part of the document because it's very interesting the way that if we go down, I'm going to call it down the rabbit hole. Okay. We'll have links to the references in here. If you go all the way down, got the subsystem design overview that It's again, it's an amount of great information as we are designing new space systems, okay? And the next step, if we want to be even more, I'm going to say, more grounded, is the following. Going a bit more in detail, it's how the SpaceX do the work. And it's kind of, I'm gonna say hidden in the last page of the document, but okay, it starts by testing and validation. Crew Dragon XLS has been extensively tested and at many levels of integration during the course of program. Component operations have been demonstrated in flight testing on Dragon 1 spacecraft, as well in formal qualification testing on the ground that meet the requirements of this standard. And they've tested the ECLS in 3 capsules. So there is extensive testing, okay? And they also mentioned in here something that was, I was really trying to understand. Why did they accommodate animal enclosure module? Oh, okay, so we could fly animals. Is that something coming from the Leica times? Something to think about. Okay. Something to think about, really. Okay, but let's go down. There is a huge part in the component qualification, more standards to follow, and post the ECLS module. And I'm not just moving around fast, but guys, that's it. That's from January 2020. Following checkouts at ECLS in the Demo 2 module, the team performed human-in-the-loop testing as the most high-fidelity demonstration of integrated life support functionality that could be undertaken before flight. You know what? Nothing of this is referenced directly in the standard, at least in the new version. So it's like, what's missing? But it's not missing. It's in another document from NASA. So you need to put your head around when you do this, okay? It's really like a great way to pick on this. And then after this, of course, there is the recommendations overall and the lessons learned. Over the past 4 years, ECLS for the Crew Dragon spacecraft, 4 years, guys, 4 years, okay? Critical to the success of the development process was the vertical integration organizational structure of SpaceX, which team develops components such as sensors, hardware, and manufacturing processes. The highly integrated nation of teams allows you to integrate and fly prototypes. I'll put this up there, okay? I'm not saying I'm a fan of SpaceX, but it's hard not to see that this is pretty much a big lesson learned. And we want to see that as well. We want to see that as well in appearing as a methodology to develop human space flight. So that's why I think it's right. If you don't read the paperwork, come on. Or if you do the paperwork. Okay. So I've provided some support on that one. There is a tiny detail, okay? And of course, I've also placed in here the Orion, Lockheed Martin. It's also rated for human spaceflight, but there is way less documentation. At least I couldn't find it. There is a little big book in there, and if you know someone from SpaceX, it's the Dragon 2 Systems Manual by Rachel Ellman. Guys, if you know Rachel, no, please ask Rachel. I would say, what are the names? Here we go. Source 2, Jason Silverman, Andrew Irby, and Theodore Agerton. They might know Rachel. So if they know Rachel, obviously they know Rachel. Rachel Ellman, please come to the stage and help out everyone with your Dragon 2 Systems Manual. Okay, it will be really interesting to have. Okay. Now, this is an example on how to apply the standard, the volume 1 and volume 2, obviously. Okay, that we cannot cover today. Now let me go and give you an overview of the standard, because we started by why is it needed, kind of what's the business case over here, okay? Well, we need to certify a system that will fly to space and with that be able to propose services to NASA. How does that look for? But it's not only to NASA, it's Axiom and whoever wants to launch. So probably we have the only flying and transportation system available. Others are, of course, in the process. We all know that. Blue Origin also have sends and has tourists in space. Okay, the standard has essentially, and I just copied the structure of the standard. So health and medical technical requirements for human performance, training, medical operations, and crew health records. And when you read these, okay, I'll put these on the center of the screen. Like, don't you think that there is something weird, correct? So these are technical requirements that are technical requirements for this is training what? These are medical operations. So whenever you read the standard starting from the top, I would say the change in here is put technical requirements in. These are what is the thing, then technical requirements or technical requirements for. That would be more logical, correct? Follow these and things will work. These are the requirements that we need. Big overview, okay, in the overall model. Health and medical, okay, over here. Right over here. Then human performance, it has many, I'm going to say many variations in there, micro EVAs and a couple of other interesting things like how do we protect ourselves from space flight radiation? Yeah, that's something to think about. Really something to think about. Then training, and overall the system of medical training, astronaut training, and crew medic. There is a standard. There are, I would say, definitions, but probably they need. We need more examples of those. Okay, if you focus on looking at each one of them, you'll see that there will be more and more. I would say more times to go through details. Of course, medical operations and crew health records, and I've got I'm going to say a blast in here in seeing and going 50 years back into the past. But I'll get to that next. Okay, so let's go to the one that looks like a system like a thing that health and medical records, and we've got 313 pre-flight preventive health care, 3111 medical management selection and certification. But the whole idea in here, and just by looking at the standard, it was like, okay, so we got something like pre-mission, correct? And then we've got in mission, and then after this launch, landing, and post-mission. That all makes sense. And there is a overall loop of medical management. So the authors of the standard decided that at this time, we'll show this one as a system, okay? And it's kind of, I think the idea is that medical management provides context for each one of them. And then medical training in mission for in-mission medical care providers. Just, okay, they wanted to show something, okay? The obvious one is this one. There are different blocks over here. What I would like you guys to focus on is when you look into the health, at least into this part, you should ask yourself, like, in what part of the mission does my company have influence on? And I would say, well, probably in all of them, but start assessing each one of them. That's something to do. Okay, then let's move into human performance. And again, the standard just doesn't put this exactly as a system, but I do think it is. But essentially, it's categories of things, okay? EVA, surface EVA, in-mission aerobic capacity. They are all in-mission fitness for duty sensor motor, in-mission fitness for matrix. Yeah, things are there. I think they can be a tight more organized, okay, or tight more easy to see. The one that I would like you guys to focus on, since we are moving on, is the Alara principle, as low as reasonable for the exposure to radiation. For that, there is an extensive I'm going to say an extensive lecture by Dr. Giovanni Parmigiani. He's a PhD, and he talks about the possibility of having cancer as we move to Mars. Okay, so that's like a really. Let me put this out there. If you do want to check this more, get more messages coming in. Yeah. Okay. Cool. I really think that's something that if you want to think about going to space, that's something to look for. Okay. The visit this lecture on YouTube. I will just show you a bit of, I would say that the most clear charts over there. And he starts with a very curious thing, man. It's like, let me open up YouTube over here. Yeah. He starts by saying that he knows nothing about space. And that's like, isn't that awesome, correct? Like when someone is just direct. I know nothing about space. This thing is not mine. And he starts that in the beginning. Like when you talk about disclosures, he
I already see something in the chat. I wonder if that's me. Let me
I'm going to say the compilation.
That is,
no,
no,
that's out there for
yeah, that is.
as well.
Oh, that's my link coming in from somebody else. Apologies for the interruption. So, as a result of this focus on the report, I want to bring up some discussion points that I think for me were the major takeaway point from this, from the perspective of
take away something in there that
what deeper questions did I walk out of this experience with, that as a statistician I really struggled with from a foundation.
Yeah, it does this in an awesome way. His lecture is just phenomenal.
A lot of the exercise,
so I'll put this in here as well,
detail,
and as well as his lecture.
But it also has to do with risk
I learned that
are quite
as I was moving to
and
understanding what
and models that
mean,
present a lot of model
the unit of radiation.
NASA does a quite thorough job of this gives an overview of how link you also have, and it's a very
from gray,
basic and
so the multiple
accessible
types of
discussion
units of radiation
of these issues that was put up by the Japanese government following the
that your organs are
nuclear power
exposed,
when one of
and there is a tissue
power plant was hit by a tsunami.
Factor. There are
anyway, this studies from them, and it illustrates how
things that are more internal,
at least
more
at
contact,
a very
you'll see
cartoonish level,
very
how
because
an effective dose
kidneys
is conceptualized.
Your lungs are effectively exposed, and then
on the far left, you have the dose that is
really to see like
external
okay, how much dose do I get?
Considered.
What kind of
then the
tissues
effective dose is the output of this process that tries to quantify
are being
the
exposed
dose
where am I,
that
and
the
what's
whole body
dose?
receives as a result of the exposure.
What I would like to think about
it's essentially a scaled weighted average that looks at each individual organ. Each organ has a weight that reflects how much of the external radiation is typically absorbed by that organ, and there are quite substantial differences from organ to organ. For example, the skin is better at dealing with radiation.
As you conduct yourself, like I'm going to Mars. How much? How much can I handle? Got it? So that's the whole point in there. So Dr. Parmigiano made a good job on. Remember, we are just in one of the little parts. Here we go. That's one of the. That's one of the. That's. And let me share that. Because when astronauts stay in the space station, you'll see that. Well, I'm going to say that lifey stuff, but that's just. I'm going to say just a minimum, not even a minimal, but. He's talking about thousands here. I really want everyone to see this. There you go. I probably can do that, but think about this. An average, whenever you are around the space station, and yes, some studies around Mercury, Gemini, Apollo, the shuttle, Hubble missions, 50 millisieverts per year. That's the worker annual. Oh, okay. I see that it's small. Let me enlarge so that that's possible for everyone to see. There we go. And I think with that, we will with that notion of that in a move to Mars, we will be exposed, extremely exposed to an overall load that can bring you I see. Well, I'm going to stop. I'm going to stop in there and see if there are any comments on LinkedIn. I think this needs a third part, most likely. Oh, cool. Cool. Very cool. Very cool. Very cool. Very cool. Very cool indeed. I'll continue just for a couple of minutes more because I want you guys to have the full idea of what is how does the standard look like, and how can it how can it help you on your day to day or in your company? Okay. So I see that. Okay, getting to conversations that's cool. That's cool. Getting to conversations that is a principal scientist of United First Nations. So it's very connected to indigenous populations and how the way that we should and maintain involvement with everyone in the space pursuit. Mr. Gus, how many EVA suits have pressure and survivability and prioritize it over mobility? According to NASA safety standards, what is the best and safe pressure KPIs that allows for enough mobility to be able to survive easily? I think these are what is the best and safe pressure in KPIs. I remember some tests that I've seen in the NASA buoyancy laboratory, but I need to go back with the right number. Enough mobility, but be able to survive easily. Well, you need to be able to survive because you'll be in there at least 6 hours. So most of the EVAs are around 6 hours. So that's something to think about whenever you engage in a spacewalk. That's definitely something to I'm going to say to not only think about, but to maintain. Correct. 6 hours with extra kilopascals of pressure could mean that you get your maximum medical. You are able to maintain that. So that definitely could be a problem. Let's see if there's any question in there. I also I saw so Vic had a question. I think Dan also had a question. And I'm not too sure. If there is no questions, I'll give you the remainder of the overview in here. And as you could see, again, Dr. Giovanni, guys, great overview of cancer on the way to Mars. Something to think about as you plan your mission. Okay, it's like, think about that. Okay, think about, because that's the thing that can really make you think in the post mission. Okay, medical operations. I don't have much to say about this, but there is a whole chapter on extravehicular activity that we need to go and check. So that's something that I can make a prior on this one. And yes, well, it usually works in closed loop. So when you mean, yes, astronauts have to have you know what's happening over there? They take diapers, man. That's it. Okay. So astronauts take diapers. That's what happens. It's the easiest way to do that. Okay. Yeah, Venkat. That's the way that we as humans need to treat. I don't know if there is because later on you need to recirculate of the waste, and there is a standard for the waste management, but yeah, that's what people take in their suits. Okay, so be ready. There is a very nice book on that from the Apollo missions on how do they work it out. Okay, so that's something to think about. That was a good. That's a nice question. In that, to be fair. I have a couple more meetings, so I want to show you the way a very what I was going to say, probably one of the most interesting records of how people use this type of things. Okay, how people in here in the crew records. Okay, let me move in here to another location. Cool. The crew health records are a way to maintain the history of the world. That's how I see it. Okay, it's probably I'll give you this because last week I don't know if I got the chance to do it properly, but I really think that if you guys have the time, go here and you will see how. Stick the pledge out, okay? And let me play this to you, okay?
Okay, status check, go, no go for LOI, retro.
We'll go flight all the way.
Green light. Fido,
No,
or go flight, guide.
Make it
We'll go with
louder.
no attitude. Control. Telcom, GNC. We'll go with the one reminder remaining flight on the jet flex. You got that, Capcom? Negative. Tell me what it is, GNC.
DV roll.
Right.
Guys,
Deputy
tell
roll
me,
disabled would like to enable it. Just a reminder sometime. That's the
Tell me-
firm.
tell me that you can
Okay, you want to go through GNC?
that you can listen to.
Ecom, you go.
It's a go
Sergeant.
sign.
We'll go.
ONP, AFD, FAO.
Go.
Green light, network. Recovery, I guess you're go.
Right.
Isn't it beautiful?
I think we have contact.
You are looking at.
Okay, Capcom, give me a green light and we'll go for
You are,
LOI.
Roger.
you are listening to when we made history, correct? And then a couple of seconds pass by, and Apollo 11 LOI. Come on, huh? Come on. How can we be so much privileged? And I think the most.
Okay, all flight controllers, go for powered descent. Retro? Go. Fido? Go. Guidance? Go. Control? Go. Telcom?
Go.
GNC?
Go.
Ecom?
Go.
Surgeon?
Go.
Capcom, we're go for powered descent.
Come on, can't you be more happy? We do need to be happy with this, for the fact that we maintain and we record history that allows us not to investigate but to use in our space missions. Okay, I think that was one of my going to say big takeaways from investigating this part of the standard. What you do will remain for the future if you use the standard. In this case, a piece of it, like I even placed a bit of the mood over here so that we were clear. Crew records,
to lift off. Crew standing by. Take -2 in the checklist. Fido
crew
status.
records starting. We
got
talk
it all.
about procedures in AI.
Waiting for guidance steering at 2 minutes. Any
Control. Where go flight? Go flight.
Surgeon. Go flight.
Just to have a link in here. I know that I would love to and I'll listen to a couple
Okay,
of more.
status check, go, no go for LOI, retro.
We'll go flight all the way.
Green light.
Okay, I'll stop there. I'll share the link with you guys over here as well. This is the website, okay? The archive of Apollo. And again, thanks for joining me today. I will be happy, and I'll send a link to my LinkedIn channel, LinkedIn, not on LinkedIn, but also to the recording of today's webinar session. We can call it, I would say, many different things. And again, if you have questions, I would say reach me out. I can help you do a process assessment of your company, of your needs to the space sector. It's something that I profoundly enjoy. And I do have, should I share? I think I can share this. I do have prepared a compliance matrix to the NASA space standard, and that is over here. Yeah, exactly. So if you want to do it with me, write your own space program, just for fun, not even for fun, like, where am I if I have to prepare myself for a system? Okay, I can definitely help with that. Again, this is usually very fun to do. Again, really fun. See if I can leave you guys with this. Lost the permissions in here. See if I can share just a piece more of content. Sometimes, yeah. Let's share the whole screen. I think you'll enjoy this part. Well, if you are an Excel geek, you will enjoy it. If you're not an Excel geek, probably not so much. But it's the overall applicability list for standard. And what we need to do is to go one by one, tailor it, and then move it to a level of execution that allows you to move in your requirements model. Requirements model looks like a very hard thing to do, but it's not. Okay, it's not. So that's something that we can work on. Okay, I letted all of them move into something that we can probably read. Okay, and listen. And again, first of all, don't forget, subscribe to my YouTube channel, where I go through many things in human space flight, in the human life and human exploration. Okay, and I hope you enjoy your Easter. It's an amazing time for all of you guys that are, if you are Christians, if you are not, it's a time of understanding from my side that it's a time of reflection, and it's a time of sacrifice as well. So all good for all. Enjoy your Easter if you celebrate. Enjoy your Friday if you celebrate your Friday.